Assalamu alaikum everyone. Today we are going to present our topics on acid properties in database management system, which is a fundamental concept in ensuring reliable and secure data transactions. This presentation is part of our database management system course at Daffodil International University. Now let's begin with an overview of what we will cover today. To understand acid properties, we first need to understand what a transaction is. A transaction is a sequence of one or more database operations, such as reading or writing data, that are executed as a single logical unit of work. For example, consider a bank transfer. The system reads the bank balance of account A, then deducts a certain amount. After that, reads amount B, and finally adds that amount to account B before committing the transaction. These steps must all be completed successfully. If any step fails, the entire transaction should be cancelled. This is where ACID properties become important. They help prevent data loss, avoid conflicts between multiple uses, ensure data remain valid. So ACID properties are essential for maintaining trust and accuracy in database system. Next slide, please. Now let's begin with the first property, which is atomicity. Atomicity ensures that a transaction is treated as a single unit. This means either all operations are completed successfully or none of them are applied. In simple terms, it follows an all or nothing rules. For example, in a bank transfer, if money is deducted from one account but the system crashed before adding it to another account, the transaction will be rolled back. This means the deducted amount will be restored. That's all from me today. Now Nusrat will continue consistency.
Assalamu alaikum everyone. My name is Nusrat Jahan, ID 24 on 15324. Now my topic's name is consistency. What is consistency? Consistency ensures that a transaction brings the database from one valid state to another valid state. All data integrity rules, constraints, cascades, and triggers must be satisfied before and after the transaction. Database constraints. Firstly, primary key unique. Secondly, not null constraint. Third, foreign key reference. Fourth, unique constraints. Fifth, check constraints. Secondly, business rules. Here is some example. One, account balance greater than or equal 0. Two, order quantity greater than 0. Three, valid uh, date range. Fourth, reference integrity. Fifth, logical data limit. And thirdly, trigger and cascades. Firstly, one delete cascade. Secondly, one update set null. Thirdly, before and after a trigger. Fourth, computed columns. And fifth, audit log enters. Now, my friend Tanvir presenting to the next topic.
Assalamu alaikum everyone. Myself Tanvir Islam. My ID is 2321573 and my topic is isolation. Isolation means when many transitions run together, they do not affect each other. When transition works separately as if it is the only one in the system. Concurrency problem without isolation. Data rate, a transition reads data written by an uncommitted transition. No repeatable read. A transition read data and find its changed by another committed transitions. Lost update. Two transitions read and update the same data. One update is lost. There are four levels. First one, read uncommitted. Second, read committed. Third, repeatable read. And the last one is serializable. And so the isolation keeps data safe when many users use the database at the same time. From the next topic, my team member Al Shahrial will give his discussion.
Assalamu alaikum. I am Imtiaz Sharia. My student ID 2411507. Now I am going to talk about to durability, the D in ACID. Durability means once a transaction is committed, it will never be lost even if the committed data is permanently saved to non-volatile storage. To ensure durability means use write ahead logging, uh, database checkpointing, backup, and replication and storage. For example, if a system crashes after a recovery scenario, transition begins, operations execute, commit issues written to wall and disk, system crash, system restarts, wall replay, data restored. Next slide will be presented by Waliullah.
Thank you, my teammates. I am MD Waliullah, ID 2411568. So I'm gonna talk about the real-world applications of the ACID properties. So if you take care of some examples here in banking systems, it is used for money transfer, ATM withdrawals, and internet calculation. It makes sure no money is lost and added, no is lost or added wrongly. And in case of e-commerce platforms, it helps in order placement, payment, unlocking stock and refunds. Everything must happen correctly for the customer. Then we can use an example for in case of healthcare systems. Well, in healthcare systems, it keeps patient records, prescriptions, and billing accurate and safe. In airline reservations, the system it helps in seat booking cancellations and avoid double booking. So these are the main topics we have written in another words in our slides. So hope you can understand. Then we can put a summary on these properties. First of all, automaticity. Automaticity means all or nothing. If one step is fails, then the whole transaction is cancelled. Then consistency means the data always stay correct and follows the rules. And isolation means multiple transactions do not affect each other. And durability means once data is saved, it stays safe and even after a crash or system restart or system boot. So ACID helps the database safe, correct, and reliable. So that was all from us on the presentation of ACID properties. Thank you for your brilliant patience. If you have any questions or any advice, you can email us. Thank you.